In the special WTF on world models, I will give you a breakdown of what this whole hype is about, where it is misplaced, and why it is a good kind of hype to have for those who are interested in the artificial general intelligence, or AGI. Thank you for listening and subscribing. I'm Alex Chaduk, and this is AGI. Listen every Monday morning on your favorite podcast platform. I will get straight to it. A world model is simply a fancy name for something that we knew all along. Since we can remember ourselves, we knew that up was up and down was down, and that was a solid part of our mental model of reality. Everything that we held true about the world around us, as well as inside of us for that matter, was and is our world model. It allows us to predict the future and explain the past. Sometimes we'll learn something new, either by reading or doing something, which makes us adjust our world model. But more often than not, we persist in our established worldview despite the evidence to the contrary, which can be viewed as an example of irrational behavior, but it often is the way it is. For example, there is a surprising number of people today who believe that the Earth is flat. That is their world model, and they use it to predict and explain the reality around them. Fortunately, these people usually avoid doing things like, for example, going to space, that would allow a discrepancy between their world model and reality to put them in harm's way. But we should not be smug about their world model, because virtually every world model that had been an established scientific consensus in the past was eventually shown to be wrong. So even the bleeding-edge world models that allow us to build amazing things like quantum computers today will at some point in the future be proven wrong and replaced with even more elaborate new world models. The world models that we carry around in our heads are not directly visible. They are defined in what we can call a latent space. I recorded an entire WTF episode on latent spaces last week that I would encourage you to listen. In that episode, I entreat the developers of neural networks to go an extra mile to make the AI models that are formed in the latent spaces of neural networks observable to the human users. An example of such an observable world model is the one shown on the Tesla's console when the car is in motion. It is very instructive to see that whenever its camera registers a large pickup truck nearby, the model immediately assumes that it's a tractor-trailer and only after a more precise measurement adjusts the animation to a pickup truck. It may look funny to a human observer, but this is in fact a highly adaptive behavior for a traffic-aware vehicle. This is exactly what a world model that prioritizes human safety over accurate representation of reality should do. This is in fact very closely aligned with the modern philosophy of science that prioritizes explanation and prediction in the world models over the accuracy of its description of reality. It does not really matter what an electron looks like, we will never be able to see it anyway. The only thing that matters is what good or harm it can do in a particular application. Since a world model is not really a new thing, it is interesting to trace how the new science of artificial intelligence stumbles in the footprints left by the science of psychology about 100 years prior. You probably know of Pavlov's classical conditioning experiments in which dogs learned to associate an unrelated stimulus, like a metronome, with tasty food when both stimuli coincided several times during the experiment. Fascinated by this idea, the American psychologist John B. Watson ran his own set of quite distasteful experiments on a 9-month-old infant and came up with the conjecture that everything there is to know about the human mind can be explained by reinforcement learning, and that the concept of a mental model is a humbug, thus ushering the dark age of behaviorism in the science of human cognition. It took almost 4 decades for psychologists to finally see past the blinders of the behavioral paradigm and allow the idea of a mental model to lose the stigma of an unscientific superstition. One of the key observations that helped unseat the behaviorism was the efficiency of language acquisition by young children, which could not possibly be explained by a laborious stimulus and response reinforcement learning. It is incredibly ironic that the language and the large language models, or LLMs, that grew out of it ushered a new era of behaviorism, this time in the field of artificial intelligence, expressed by a pervasive, almost self-evident idea that if we encourage rational behavior in an LLM agent and discourage the irrational, the agent will somehow grow rationality. Yes, some kind of rationality can emerge through sheer statistics, or if the agent simply memorizes all rational and all irrational behaviors it has seen in its training set, but the efficiency is simply not there even if we throw another $1 trillion at it. The idea of the need for an abstract mental model of the world gradually emerges as a consensus among the leading scientists. It often takes different shapes, and different paths seem to lead to it. Some say we need to make the AI forget some of what it's learned so that it can generalize better, in other words, make the AI smaller. Some say the AI needs empirical data, direct first-hand observations of the world, not only textual or visual data that the frontier models are trained on. In other words, it needs more data. This focus on the training data, although definitely important, obscures a crucial aspect, which is the world model itself. We have a set of very successful algorithms that are capable of generating a language model out of textual data or a visual model out of visual data, but language and vision are human interfaces to the world. They exist on the surface of our perception. Assuming that one can build a deep mental representation of the world by reinforcement learning on the shallow perception is behaviorism all over again. Another pernicious idea that keeps haunting the scientific discourse in artificial intelligence is that world models can only be derived from data. This idea is so obviously in disagreement with the way that the rest of this civilization builds its scientific models of reality. The normal flow of scientific discovery is that a scientist first forms a new mental model of the studied phenomenon and only then tries to construct an experiment to collect the empirical data that will either confirm or refute the world model that the scientist has proposed. So the engineers building AI got it backwards. On the surface, the real scientists do seem to look at the data a lot, but they do not derive their models from it. The data does help to create the new world model by providing both inspiration and early refutation, which helps a skilled scientist to avoid proposing new models that obviously disagree with the existing data. That saves a lot of time and money when it comes down to experimentation, but that's about it. The spark of a new world model comes from the scientist, not from the data. I did hypothesize in an earlier episode that LLM hallucinations may be the shadows of that scientific spark, but I may well be too kind to LLMs, who knows. By extrapolating the delusions that the AI industry seems to develop on its trajectory, I will not be surprised that at some point in the near future, the AI researchers start talking about the unified world model for artificial general intelligence. This thing is both unnecessary and quite likely impossible. Instead, an AGI agent should develop and maintain a loose family of world models. Like a good scientist, it should be able to entertain two conflicting world models of the same phenomenon at the same time. Otherwise, how can it construct a valid experimental design that will allow it to test both models and provide empirical evidence that refutes one but not the other. Once we get the agent on this principal path of discovering new world models that will help us solve old problems, only then we will be able to say that this is AGI.